All right, in our previous video, we took a look at the different ways that you could identify if a function was quadratic or not, based on looking at the equation, looking at the graph, or even just looking at the raw data, the ordered pairs. So today we're going to focus on specifically the graphs. So we said the graph of a quadratic function is called a parabola, and it looks like these shapes here, whether it's U-shaped or like an inverted U-shape that we say is open down, okay, the one where the arms kind of point downward. And what we're going to do is we're going to focus today on identifying the vertex of a parabola, the x-intercepts of a parabola, the y-intercept of a parabola, the axis of symmetry of the parabola and what that is, also the maximum and minimum values of that parabola, of that quadratic function, and then also relate that to the direction that the parabola opens, like I said, whether it opens up, like in the first two examples, or opens down like the last one. So that's our focus for today. So let's just real quick go through our vocabulary for what those different things mean that I just brought up on the previous page, starting with minimum and maximum. So minimum is exactly what it sounds like. A minimum value is the lowest value possible. So in this case, it's the lowest point that's on a parabola, but the trick is that's only when it opens up. For example, if I were to draw a parabola here that opens up, kind of a U-shaped, rounded at the bottom, we can see that there is a definite lowest point on the parabola. It's kind of right smack dab in the middle. Okay, that would be the minimum y value. So if you think about on your graph, there's the x-axis and the y-axis. The y-axis gives you that up and down value. Okay, so that's why we're looking at the lowest y value is the minimum. The maximum is only going to happen if we have a parabola that opens down. Okay, for example, something that looks like that. That's going to have a highest point at the top or the peak of the parabola, and the y coordinate of that point, the y value, is going to be the maximum value on the parabola. It looks like that. Okay, so if it opens down, there is no minimum value because those arms indicate that the parabola continues down forever. It never stops. But there is a highest point on the parabola at the top, which we call a maximum. All right, so those points that I was just referring to, where we get the minimum and maximum values, kind of like the middle of the parabola, that point is actually called the vertex of the parabola. And we can identify a vertex using the coordinates of that point on the coordinate plane with the x-coordinate and the y-coordinate. Okay, so it represents where the minimum and maximum values occur. It can also be thought of as the middle of the parabola. Now, the axis of symmetry is probably the trickiest one because it's a lot of words that we're not used to using. So in this case, axis, where have we heard the word axis before? Well, just like when we work with graphing, we have an x-axis and a y-axis, which are just lines that create our coordinate plane. So the axis of symmetry is a line. It's a line of symmetry, meaning that it's a line that kind of says everything on one side is a mirror image of everything on the other side. It's like a reflection line. Okay, so the axis of symmetry will always go right through the vertex of the parabola. So on those parabolas I drew up above, my axis of symmetry, which we usually use a dashed line to represent the axis of symmetry, is going to be a vertical line that goes through the vertex, and it makes the left side and the right side symmetric, meaning if I had a sheet of paper with that parabola drawn on it, I could fold it on that dashed line, and the left side and the right side would be the same. They'd match up when I fold it together. Okay, that's our axis of symmetry. Now, because it's a line, we can give an equation for that line of symmetry. And any equation for a vertical line will always be x equals a number. And it just depends on where that line crosses the x-axis. We'll see some examples here in just a little bit. The other one, is it on here? I did not put it on here, but y-intercept and x-intercepts are going to be the point or points where your parabola, your graph, touches or crosses either the x-axis for the x-intercept and the y-axis for the y-intercept. Let's look at a visual here. This one includes our y-intercept at least. All right, so here we have our parabola. So our quadratic function is in graph form here in the background with that lighter shaded red. So that would be some type of quadratic equation that has the graph solutions. And what we see here is we have a point at the top of the parabola. Now, because it's at the top, this would be a maximum value. So the vertex appears at the maximum value of 4. Okay, now the vertex has the coordinates where we use the x and the y together. So for my vertex, if I follow down to my x-axis, got to be careful. It's not just 1, 2. So if I look at the rest of the numbers on my x-axis, I see that 2 is actually over here. So this is 1. Okay, so from my vertex, my x-coordinate is 1. And now if I follow from my vertex over to the y-axis, sorry, that's a bad y, I get 4. So my vertex has the coordinates 1, 4. And we see it is also listed as a maximum because it is the highest point on my parabola. For the axis of symmetry, we always write the equation of that line of symmetry. And all of our equations are going to be x equals a number anytime that you are referring to a vertical line. That's from that previous unit on linear equations. So x equals a number, and it's always going to be whatever value this line crosses the x-axis through. So right here, it crossed the x-axis at 1. So our axis of symmetry has the equation x equals 1. And that's because every single point on that axis of symmetry would have an x-coordinate of 1, whether it's 1, 0 or 1, 2 or 1, 3. Anything on that line is going to have an x-coordinate of 1. Now the y-intercept is that point where our parabola crosses and meets the y-axis. So that's the one point where my parabola crosses and touches the y-axis. It appears to be exactly halfway between 2 and 4. So our y-intercept in this case is 3, but we're going to label it using the coordinates. Okay, it's above the x-axis at 0, and it's right on the y-axis at 3, so it has the coordinate 0, 3. So for the next one, I would encourage you to actually try this. Identify the coordinates of the vertex, give the equation for the axis of symmetry, and then also the y-intercept as an ordered pair. So please pause the video, and when you're ready, continue. All right, your vertex on this one. Okay, vertex is at the bottom of the parabola, therefore it represents a minimum value. But for my coordinates of the vertex, it has an x-coordinate between 0 and -2. So the x-coordinate is actually -1. And my y-coordinate, let's see, what would that be? Let's see how I'm counting. From 0 to -2, so that would be -1, -2. This appears to be -3 down there near the bottom. So the vertex is at -1, -3. So -3 is the minimum y value that appears at any point on that parabola. Because it opens up, the arms are going upward, all the y values are bigger than -3 on the rest of the parabola. So my axis of symmetry, I just have to figure out where does it cross the x-axis. Well, it's right, again, in between 0 and -2, so that would be -1. So all points on that axis of symmetry have an x-coordinate of -1. And you'll notice even the vertex, which is a point on the axis of symmetry, also has an x-coordinate of -1. And that's no coincidence. Those two numbers will always match. Last, I have my y-intercept. So did you find the place where the parabola crosses the y-axis? It's right there. Now, we got to be careful. I just scribbled over the little number, but we know it's below the origin, so that's going to be a -2, not a +2. Remember, with y-intercepts, the x-coordinate is always 0 because it's directly either above or below the origin. And then my y-coordinate is that value on the y-axis, 0, -2. So now let's do the same thing, but we're going to use the Desmos graphing calculator to help us out. So we're going to graph this equation, y equals x squared plus 2x minus 1. So again, the Desmos graphing calculator is at desmos.com. When you get to desmos.com, hit graphing calculator. It'll take you to the graphing calculator. And from there, we can type our equation on the left-hand side. Y equals x squared. So I'm going to hit x. I can hit this little keypad and then the squared button. I believe it was plus 2x minus 1. Let me double check that though. X squared plus 2x minus 1. So what was I supposed to get from this? I need to see if the parabola opens up or if it opens down. And I think we can agree on this one that there's a low point and the arms are going upward. So this one opens up. Now also, because there is that low point down here at the bottom of the graph, we would say that is a minimum value because it's down at the bottom. So let me mark that quick. It opens up and there's a minimum. Opens up and minimum. Next, I want to actually go to the coordinates of the vertex. And our vertex is right here at the bottom. Now, in Desmos, when you graph an equation, as long as you're still in this box, if I move out of it, notice the little dots disappear. If I go back into this box, it's like highlighting all the important points on that graph. And my vertex is right there at the bottom. If I even click on it, it makes it dark and it shows me the coordinates are at -1, -2. So again, that's my vertex, -1, -2. Now, for my equation for the axis of symmetry, remember it's always going to be x equals a number, and it's that x coordinate of where the line of symmetry goes right through the middle of the vertex. Now, I don't see the line here, so I have to use something else that I already know about this. Now, I know that my vertex had an x coordinate of -1, right there again. So my x coordinate's -1. So that means my x value of this line that would go right through the middle of the parabola is always going to be -1. So my axis of symmetry equation is x equals -1 because that was the x coordinate from my vertex. It'll always match like that. Last thing we need is the y-intercept from our graph. So you'll notice again, as long as you're in this box or if you click right on the parabola, you will see these other important features. So there's an x-intercept. That was our vertex. This is the dot where it crosses the y-axis. Remember, the y-axis is this vertical line here. So my y-intercept is at 0, -1 because it crosses the y-axis at -1. So 0, -1, my y-intercept. So that's how we can use Desmos to help us find those important features as well, if we don't already have the picture for us. Let's just look at one more. Here's another example. X equals -x squared plus 4x minus 2. We'll answer the same questions. So I'm going to go back to my graph and I'm going to change in, type in the equation. And I would encourage you actually to maybe pause the video at this time and type that in yourself and see if you can get the correct solutions here. We'll go through that as soon as you hit continue. All right, so here I have my equation, y equals -x squared plus 4x minus 2. Remember, if you're inside this box where the equation is active, it'll show you all the important dots that you need here. I have a vertex at 2, 2. I see I have a y-intercept at 0, -2. I can see also that my parabola opens down because the arms are moving downward. That's where it goes on forever. And because of that, I have a highest point of my parabola right here at a y value of 2. Notice it never goes above a y value of 2. It's everything that's smaller than that. So I have to start kind of filling this out. So it opens down, and there is a highest point, which we would call a maximum. So opens down and maximum. Did you have that? Our vertex was at 2, 2. Our y-intercept, we said, was at 0, -2. The only thing missing there is that equation for the axis of symmetry. So remember, if we have a parabola that looks like this, our axis of symmetry is going to go straight up and down through that highest point, that peak or that vertex. And we always use the equation x equals a number, and it's whatever the x coordinate of that point is. Well, we have that because that's our vertex. The x-coordinate of the vertex was 2. So our axis of symmetry equation is x equals 2. So take a look, check all 5 of those parts on yours, and let me know if you have any questions. Otherwise, you may go ahead, try the recommended homework and the quiz for the day.